and sharing. And I want to look at, I took the liberty of cutting and pasting the important dates that we had spelt out previously into the start of today's notes. So, excuse me. Homework 5.1 is due by the end of the day today. That's the homework on, no, this is not your class. Let's try that again. I'm sitting and thinking, no.
Ours is 8
Yeah.
point something.
Yeah, there you go. This would be better. Homework 8.5, which is the annuity assignment, is due by the end of the day today. Homework 8.6, which is the assignment that deals with what we talked about last class, which is the car loans, is due by Monday. Homework 8.7, which we're dealing with today, are the mortgages, is due on the 28th. Test 4 will be due by Saturday, so that'll be not this weekend, but next weekend. And hopefully one day next week we'll go over a practice test. The last day that you can do homework in my math lab is Sunday the 2nd. Project 4, which will be a mortgage project, is due a week from Monday. After we look at mortgages today, I'll walk you through it. If not today, I'll walk you through it on Monday. And the final will be due by the end of the day on the 5th, which is Wednesday. Does anybody have questions about any of those dates? Does anybody have questions on any of the problems from homework 8.5? I believe we went, go ahead.
Oh, that was the one that was due. That's the one that's due today.
Right.
Oh, I haven't started it yet, so I wouldn't have questions.
Last class, we had went over that last question, which I think was the most challenging of all of them, that question 10. I took the liberty today to pull out 2 of the questions from homework 8.6 to look at examples before we start section 8.7, because they're a little different than some of what we did in class. And so this is from homework 8.6, question number 5. Again, when you do it, your numbers are going to be a little bit different, but this kind of deals partially with what we did last class. It says we're going to buy a car for $58,000 and we put $11,000 down. The dealer is giving you a choice of 2 incentives. One, $3,000 off the price of the car and a 5-year loan at 7.17%. The other, no price, nothing off the price of the car, but free financing over the 5 years. What's the difference in monthly payments between the 2 offers? Which incentive is better? And here they give you that payment formula. Again, the payment formula, the way it's written on the formula sheet that I gave you, this denominator is in parentheses. Whether it's there or not, you need to type those parentheses in around the denominator, because there's work in there, that order of operations, those parentheses are important. Usually if you have a fraction like that, an algebraic fraction, there's invisible parentheses around the numerator and denominator. Here in the numerator, it's not as essential as in the denominator. So let's look at this. The price of the car is $58,000. But does everybody know how this down payment works? The idea that you have to pay some of the money in cash, and so you're not borrowing all of it. So here, when we subtract that down payment, what we still owe on that car is $47,000. Now, if I look at incentive A, in incentive A, their car is $47,000, but they're taking $3,000 off. So for incentive A, what we're borrowing, our principal is $44,000. They're telling it's a 5-year loan. With car loans, they'll be monthly. So N times T means there'll be 60 payments, 5 times 12. And our rate is 7.17%, which would be 0.0717 as a decimal. Is everybody comfortable with that information?
Yeah.
All right, then next, let's use that payment formula. I'm not going to rewrite the formula because it's right here. That'll give me 44,000 times 0.0717 divided by 12, close parentheses, over open parentheses, 1 minus open 1 plus 0.0717 over 12, close parentheses. And remember that exponent has to be negative. So we're raising it to the negative 60th power. And so let's go through and do that to the nearest cent. Before we do, is everybody comfortable with the way I substituted?
Yeah.
So please type that in on your own and tell me what you get.
$10,497.43.
Okay, I'm thinking if we're borrowing $44,000, monthly payments of $10,000 seems a little high. So scroll back through and look at what you typed. Did you type 44,000 times parentheses 0.0717 divided by 12, close parentheses?
Oh, I forgot the 12. My bad. Let me retype it. Sorry.
Okay. Did anybody else get an answer yet?
I don't know. I got this loan number like 4.28465. No, that's
Okay.
not right.
4.28 would be like $4.28, and I think that's low for a loan also.
Yeah, it is. Now, when we're done with the parentheses, that's 0.0717 divided by 2 and close the parentheses. Do we
And
have
that's
to do
dividing by 12, not 2. Go ahead.
that's what I meant to say, 12. That line in the middle,
That's
Do we-
another division sign.
I did that. I did the division. Yep.
And then did you open parentheses 1 minus open parentheses 1 plus 0.0717 divided by 12, close. Did you
Yeah,
remember
okay.
that to raise it to the negative 60th?
Yep, I did that. So I don't know where I messed up. I'll
Okay.
try it again. I'm gonna do it again.
Well, with your calculator, before you try it again, arrow up, and you should be able to see what you type. And
Alrighty,
just
cool.
double check that you typed every number right. When I get an unrealistic answer, that's the first thing that I do is I double check and scroll through to make sure I typed everything in okay. Did anybody else get an answer yet?
I got 874.78.
Okay, but we're rounding, so you've got to round up. So I'm thinking that should be $874.79. Did anybody else get that? I don't want to go on until I'm sure that everybody in class got that answer from their calculator. So I'm going to wait to hear back from all of you. Go ahead.
I got that.
Good.
I got it too.
Me too.
Marilyn, you got it this time?
Yep.
Okay, good. Anybody else not get it? Then let's look at that option B. Option B, there's no rebate. So our principal is that $47,000. But there's no interest. We're not being charged interest. So how are we going to figure out these payments? If I put in 0 for the interest, that whole great big crazy formula is going to turn out to be 0 over 0. Does it make sense that we've got that $47,000? And if we're going to pay it for 5 years monthly, doesn't it make sense that we'll be making 60 payments? And if there's no interest, it's just what we owe divided by the number of payments. So let's take that 4,700 and divide it by 60. And that gives me that my payments are going to be $783.34. Does that make sense, everybody?
Yeah.
And so now look at, even though this time we got an extra $3,000 off, interest-free is a lot less expensive. For the final answer, they'd ask you to subtract those and take your difference. This question, all right.
Yeah.
If so, the next question that I wanted to look at was question number 6 in question homework 8.6. And this question's different because it's not talking about loan payments, but rather I think I had asked you folks to read section 8.6. And when you read that section 8.6, they talk about the idea that when you own a car and drive a car, the car payments aren't your only expense. I think anybody who's driven a car that they've had to cover the cost of on your own, you realize you've got to, besides paying for the loan, you've got to pay for the insurance, you've got to pay for the gas, you've got to pay for the repairs, you've got to pay for the license and everything else. And so they talk about this idea that if you were to add up all of those costs on an annual basis and divide it by the number of miles you would drive, there's something that they consider a cost per mile. So they're saying, let's say our operating costs are 26 cents per mile. So operating costs would probably be things like gas, tires, and the like. And then there's the ownership costs, the insurance, the licensing, the loans, and all of that. So they're saying in total, we're paying 98 cents a mile to drive this car. Part A says, all right, so if I'm paying 98 cents a mile, and I drive 20,000 miles, what would the total cost be? The total annual expense. Anybody have an idea as to how we would do this? If it's 98 cents a mile and we're driving 20,000 miles.
We'd multiply them.
Beautiful. So when I take that 0.98 and multiply it by the 20,000, what do you get?
19,600.
And so that will be my answer for A. And now this is where Mr. Blitzer starts trying to be like your dad or your grandpa or something and says, so what if the total annual expense for the car, instead of getting the car and paying for it, you deposit into a IRA, which is an annuity that earns 8.5% compounded yearly, which, okay, I know that's a high interest rate for now, but we'll run with it. How much money would you have at the end of 6 years? And they give you the annuity formula. And so here, that money that we'd be putting in every year is that 19,600. The rate is at 8.5%. And again, make sure you remember to change that into a decimal. It's happening yearly, so N is 1. And T, we're asking about 6 years. So I think obviously N times T, 1 times 6 would be 6. When we substitute into this formula that they gave us, P is 19,600, parentheses, 1 plus 0.085. Is everybody all right? If I divide it by 1, I don't really have to show that division, so I'm going to just write it as 0.085. I'm raising that to the 6th power.
We have to do two parentheses after the 19,600?
Yeah, there's 2 parentheses right here, huh?
Okay,
Okay.
thanks.
And I know sometimes, especially if looking at the computer too long, sometimes I don't see things. So be careful. Again, I suggest, you print out their formula sheet. I think the font on that is a little bit bigger. And then the denominator, he did not put parentheses around the denominator on the formula sheet that I gave you. I did because, again, it's important that you put the denominator in parentheses. He's going on the assumption that because it's in the denominator, everybody knows those extra parentheses are needed. But my rate is 0.085, and I'm dividing it by 1. So again, we don't need to show that division by 1. So if instead of buying this car and paying 98 cents a mile to keep it going, we saved our money and put it in our bank, how much would we have in 6 years? So that's the formula filled in. I'm going to ask you folks to please go through and type it in. And not going to lie, I just caught myself making a careless mistake typing. And I'm looking at this in amazement. I don't think my cars are fancy enough that I end up paying 98 cents a mile, but you get the picture. Is everybody getting a very large amount of money that you would have at the end of those 6 years? Let's do it to the nearest cent. It would be $145,608.98. Did, first of all, everybody get that value from their annuity formula?
Yeah.
Okay, I heard 1 yes. Thank you for answering. All of you silent
Yeah.
people, I go on the assumption you're okay?
Yes.
Okay.
Yes.
And so just an interesting thing that you have to consider when purchasing a car, not just the cost of the car and the cost of the interest, but also the cost to operate it. So I like the way he introduces that in that section, which again is why I'm asking you folks to read it. So did anybody have any other questions on any of the problems from that homework 25, section 8.6? If not, today we're going to use that amortization formula that we talked about before to look at mortgages. And a mortgage is a fixed payment loan for property. Since it's a fixed payment loan, we're going to use that same formula that we used for car loans. P is the loan amount. R is the rate. And again, you want to express it as a decimal. N is the number of payments per year. And if it's not stated with a mortgage, we'll assume that it's 12, because usually people make monthly payments on mortgage. I want to say at one point in time, several years ago, when I was teaching this class, I had a student who, when I said that, spoke up and said that they actually worked in a local bank in the mortgage processing section, and that the bank that he worked at was beginning to change that. And so people could get mortgages where instead of paying every month, every 4 weeks, you could pay something like every 2 weeks or every 3 weeks. And so that is something that I guess could be flexible depending on your lender, but most people make monthly mortgage payments. T is going to be the time in years. And PMT is going to be your regular payments, your regular fixed payments. But hopefully by the end of today, if not the beginning of Monday, we'll look at that idea where that's what they expect you to pay. And I think we talked about this with car loans too. At some point in time, if you ever find yourself in a slightly better financial situation, it really benefits you to think of that as the minimum payment. Because if you can send extra money in with something like a car loan or a mortgage, you end up shortening the time of the loan, and you save yourself a lot of interest. So, all right, so let's look at an example. And I have to apologize, I've been using the same example for years, and periodically I go through and I look at Zillow and look at different houses that are for sale in the area. And so I'm not so sure this dollar amount is that realistic anymore, but to keep the numbers nice, let's say in our example, we want to buy a house and we negotiate the price to be $100,000. Which I think when I first started teaching at the college, that $100,000 estimate for certain areas was rather high. Yeah, but I think the cost of homes in Western New York have gone up significantly. When you buy a house, you're expected to make a down payment. The down payment is usually a % of the price. That you have to pay in cash up front. I think that most of you can remember several years back when there was a financial crisis caused by a housing bubble. And part of the problem that had occurred then was usually traditionally mortgage loans have been a very safe investment for investors. You know, you'll get your loan and at some point in time, the bank will sell that as an investment to somebody else. And usually mortgages are pretty stable. They're not very high risk. And because of that, they were trying to make more and more mortgages because it was a good investment. And in trying to make more and more mortgages, they got more and more careless, and they stopped checking to make sure people could afford the homes that they were buying. And they also stopped requiring people to make down payments. I mean, part of the down payment is to make sure that you were able to save enough money to do this, that you're fiscally responsible. And the other part of a down payment is to tell the people you're buying the house from that they can take it off the market now because you're serious about buying it. I know at one point in time when my husband and I were selling our second home, we got into a arguing match with the people who were buying it because they found that there were extra costs that they were unaware of. So they wanted us to bring the price down. And I remember being very angry and almost losing my voice arguing with these people. And our lawyer came over to me and took me out in the hall and said, don't worry about it. They're not going to back out because if they do, they'll lose their down payment. So again, that down payment is money that'll go to the people selling the home no matter what if you back out unless there's something stipulated in the contract. So sort of interesting. So in our example, let's say that we make a 20% down payment. And so our down payment is 20% of the cost. So we'll take that 20%, that 0.20, and multiply it by $100,000, which means that we're going to somewhere have $20,000 in cash that we're going to give to a representative of the owner to say that we're good for purchasing the house. So now the mortgage amount is what we have to borrow. And so that's usually the cost of the house minus the down payment. This is going to be our P in our formula. So the cost of the house was $100,000 and we're putting $20,000 down. And so our mortgage amount is $80,000. Mr. Blitzer brings up, in addition to the mortgage payment formula, the idea of points. And I have to say that points was something that I had not heard of before we bought our first house. A point is 1% of the mortgage amount. It really has nothing to do with the mortgage payments, but rather it's an additional fee that the lender charges. It's money that you have to pay at the closing. And it's not a part of the loan payments. I think that currently most mortgages do not charge points. However, sometimes you can get a nice interest rate on a home loan right now. But sometimes if you pay points, if you pay a little bit of extra money up front, they will give you a lower interest rate. So let's say in our example, the mortgage amount is the $80,000. And we need to pay let's say 1.5 points. Okay, 1.5 points is 1.5% or 0.015 of the mortgage. So to find that percent, we'll take that percent as a decimal and multiply it by our mortgage amount. And when you do that, what do you get?
$1,200.
$1,200. I know every time we bought a home, we have had to pay points, and you'll see in a minute, it's amazing to me that they have to get that extra $1,200 or whatever from you when you actually look at the interest that you pay on a mortgage. It's amazing. So now going back to our example, our mortgage again is $80,000. And we want to find the payments. But we're given two choices. Choice A, we can have a 30-year mortgage at 4.32%. Choice B, we can have a 15-year mortgage at 4%. So I'm going to, in the middle here, write that formula. The payment is equal to the mortgage amount times the rate divided by the number of payments in a year over parentheses 1 minus parentheses 1 plus that R over N, close parentheses, again to the negative N to close. And because it's not stated here, both of these are going to be monthly. So let's start at looking option A together. The 30-year, our principal again, our principal, our mortgage amount is $80,000. Our rate is 4.32%, which is 0.0432. We're making monthly payments for T is 30 years. And so when I look at N times T, when I take 12 times 30, I get that over time we'll be making 360 payments. When I substitute that into the formula, I'll get that the payment is equal to P is 80,000 times parentheses 0.0432 divided by 12, close parentheses, all divided by open parentheses, 1 minus, open another parentheses, 1 plus 0.0432 divided by 12, close parentheses, to the negative 360th power. Before we go through and start typing this into our calculator, I just want to pay homage to past times. Can you imagine raising something to the 360th power if you had to do that by hand without a calculator? That would be insane. So let's go through and let's type this in. Do you guys want me to talk you through what I'm typing?
Sure.
So it's the 80,000 that I'm going to go times. I'm going to open parentheses. I'm going to type in my 0.0432. Then I'm going to take that and divide it by 12 and close my parentheses. When I close my parentheses, that part actually physically looks like that fraction. Then I'm going to take that and divide it by, I'm going to open my parentheses, 1 minus, then I'm going to open another parentheses, 1 plus 0.0432 divided by 12. I'm going to close my parentheses. I'm going to arrow up to get an exponent. I'm going to press that negative sign, again, not subtraction, but that negative sign, 360. Close my parentheses. Keep my fingers and toes crossed that I typed all right. And when I hit equal, let's round up to the nearest dollar. Sometimes in the homework, they ask you to round to the nearest dollar, sometimes to the nearest cent. To the nearest dollar, this would be $397 a month. Before we go further, did everybody get that?
Yeah.
Yes.
Okay, so a little bit under $400 a month. Guess it's not too bad to own your own home. Let's look at B though. B, our principal is still that $80,000. Our rate is a little bit lower. 4% would be 0.04. And you're going to find with a shorter loan, the rates are usually a little bit lower. We're going to still make those monthly payments, but this time it's only 15 years. So when I take N times T, 12 times 15 will give me 180. And so my payments, substituting, P is 80,000 times R is 0.04 over N is 12. I'm sorry, that zero's messy. Divided by open parentheses, 1 minus open parentheses, 1 plus 0.04 divided by 12. This time we're raising it to the negative 180th power and closing that past parentheses. So this time I'm going to ask you folks to type that in and to tell me what you get.
Are we rounding it to the nearest dollar?
Yep.
Okay, I got 592 then.
Ooch, $592. That's what I got also. How about anybody else?
Yep.
Yep. Wow. What would you rather pay? $397 a month or $592 a month? I'm thinking the $592 sounds like the better deal. I'm sorry, the $397 sounds like the better deal.
Yes.
But let's go through and let's look at the total cost. The total cost is going to be your payment, but you have to multiply that by NT, the number of payments. So in A, we're paying $397. NT, we're doing that 360 times. And so when I take that 397 times 360, we're actually paying $142,920 for that $80,000 loan. The other one, our payment's $592. Wow, that's a lot higher, but we're paying it 180 times. So when I take that 592 times 180, I'm actually paying $106,560 for that $80,000. And do you notice that while the payment is higher, because we're only doing it for 15 years instead of 30, the overall cost is much lower. Sometimes, in addition to finding the total cost, you're asked to find the total interest. And the total interest is going to be the total of the payments minus our original mortgage amount P. So with that first option, when I take the total of the payments and subtract the $80,000, we're paying $62,920 in interest. When I look at that second option, the total of our payments is $106,560. And when I subtract that $80,000, the total of our interest is $26,560.
What a huge difference.
What a huge difference.
Mhm.
And that's why if you're buying a house and somebody sits you down and looks at the difference in the payments, I'm positive everybody is geared towards that lower payment. But realize if you take a shorter loan, you pay it off much quicker. And in the greater scheme of life, you save a lot of money. Problem arises that a lot of times you might qualify for that $397 payment, but not for that $592 payment. In which case, again, like I said before with the car loans, if you get to a better place financially, you can start sending extra money in with your payments. We're going to wait until Monday to look at how that's done with an amortization schedule. The idea that the extra money will go directly to the principal. And so as the principal goes down, the amount of interest that you owe goes down, and you can still pay it off quicker and save a lot more money. I know my cousin's husband years ago did not like being in debt at all. And so when they bought their first house and they got, the traditional 30-year mortgage, he just started sending all sorts of extra money in all the time, just being tight with everything else. And I think they were able to pay that mortgage off in 10 years, which really, if you think about 20 years worth of interest, really saves them a lot of money. So I'm going to stop here in terms of this example. I'm going to wait until Monday to look at the next thing that we're going to look at, the amortization schedule. And in the time that remains, I'm going to go through and walk you through what that project is. So if I can get the touch screen to respond to my fingers, learning module content. If I go to projects, I forgot to upload it for your class. I think we have time. I know I uploaded it for the other section, and I will upload it for your class immediately after class. But the other section, project 4. Where did it go? There it is. What I want you to do is I want you to, from a newspaper real estate section or Zillow or one of those little magazines you see in front of a store or somewhere, Craigslist or whatever, find a house you want to buy. I'd appreciate it if you would get a picture of the listing and maybe a description of the house. It should be fun. I've gotten some students who have bought $1 million homes somewhere, which is always interesting to see. And then I've also gotten some people who didn't want to spend money and found like their $20,000 home somewhere. After you do that, you're going to go to this site here and you're going to find the current interest rate in this area for a 30% year loan and a 15-year loan. I want you to find the rates for those conventional loans, write that rate down. For both of them, I want you to see what your 20% down payment is and what your monthly payments are. Then for the 30-year loan and the 50-year loan, after you find the payment amount, I want you to find the total of the payment and the total of the interest. And then write a couple paragraphs comparing them. All right. So hopefully it's kind of fun and interesting to go through and try to pick out a house you want to buy. And I also think that like that 4.32% sounded pretty peculiar. But again, I think last semester when I went through and picked that for the examples, I actually, well, it was the last semester I was on campus. We actually went to a website and searched for the current interest rate in the area. I think right now the current interest rates might be a little bit lower than that, but hopefully, you know, it should be an interesting project for you. Okay.
So it's pretty much what we just did just now.
Right, except I'm not
Yep.
asking you to do points. And I'm asking you to take the time to look for a house that you find interesting. You're gonna, please, I know that there are mortgage calculators out there on the websites. I don't want to use you to use a mortgage calculator. You will not get full credit if I don't see your work, identifying the variables, showing the formulas, substituting it. Okay.
So you want us to make sure we do the formula and the steps like you just went over with us step by step, right?
Right. If all I have are answers, you're not getting full credit. I want to see your work. Okay.
Sounds good.
So, and I want you to submit information and hopefully a picture of the house you want to buy and submit pictures of all your work. There will be a Dropbox in there with this sheet within the next hopefully 10 minutes. So, all right.
Another question, do we have to do like newspaper? Can we look for the house online and print that out online?
You can look
Okay.
online. I play the Zillow game all the time. In ideal world, I'd love to have a house overlooking one of the lakes, either Lake Erie or Lake Ontario, when we retire. And so periodically I kind of just open Zillow and look at all of the houses that are for sale. Sure, if you want to do it that way, wherever you get it from. So,
All right.
okay. Any questions?
I do. On the exam, considering, are we getting the same amount of problems like we have on our previous exams?
I'll
same
tell
am-
you
What is it that we normally get? 30, right?
It varies from test to test. In terms of the final exam, can I, do you mind if I on Monday have all that information for you instead of scrolling
Yeah.
through it now? But I want to tell you that on all of the questions on the final exam are questions that were on your tests already. So I picked a handful of questions from each of the 4 tests.
I was concerned about the 4th exam, considering that some of these
Oh.
problems are time consuming, you know?
Oh, there are much fewer.
Okay, all right.
Okay. Well, and again, we'll go over a practice exam probably next week, Wednesday. Okay.
Yeah, I already
All right.
printed out, so.
Okay.
All
All right.
Thank you.
So have a good weekend, you guys.
You too.
Bye,
thanks.
you too.
Again, if you're doing the homework and you have a problem, don't forget that Ask My Instructor button's there. Okay. Bye-bye.
Okay, bye.